All right. Welcome, everyone, to this afternoon's Inbound Logistics webinar series presented by Transfix. I'm Jeff Vida, and I will be your moderator today. Before we get started, I want to go through some of the protocol. You will all be muted upon entry. We do have a dynamic data duo on deck for our discussion, but from the onset, I just want to stress that this is an open dialogue, and we encourage everyone in the audience to submit questions throughout the webinar. If you're listening through your laptop or your computer, you can submit questions through the control panel to me directly. Please submit questions along with your name. We do have the last 10 minutes set aside for a Q&A segment. Our topic today, data, how do I harness it, is one that's near and dear to shippers' hearts. But before we get going, our two featured guests this afternoon are Filip Piasevoli, Senior Data Scientist, and Jonathan Salama, CTO and co-founder of Transfix. Jonathan and Phil will be walking us through three data topics that are sure to resonate with the audience. The first is how to gather, harness, and model data in the hopes of reducing detention and accessorial costs. The second topic will touch upon the kind of cost savings that are being realized by companies who have embraced reusing the same carriers. Reliable capacity and familiarity has a direct correlation to lower costs. And finally, Phil will walk us through some of the data pitfalls that shippers would be wise to avoid. So Jonathan and Phil, welcome. The floor is yours, gentlemen.
Hi, Jeff. Thanks for having us, and thanks for everyone for joining. My name's Jonathan Salama. I'm the CTO and co-founder here at Transfix. I have a very heavy engineering degree, and I started my introduction to logistics as we started Transfix. Very excited to be here.
Hi, everyone. Like Jeff said, my name is Phil. I'm a senior data scientist here at Transfix. We generate a whole lot of data ourselves. Together with my team, we analyze and we actionize our own data, along with various market benchmarks, macroeconomic data, along with helping our own customers really get control over the data that they generate. Great. So to give you an idea of what today's going to be like, we're going to go through a couple of concrete examples. But what I'd like you all to keep in mind as we go through is we're really pushing for you to store as much data as possible. If you take the example of analyzing carrier cost, there are some basic data fields that you're going to want to keep track of. And they're pretty obvious. Who the carrier is, how much was paid, where the load was picking up and delivering to. But in order to answer more nuanced questions, you also need to be collecting more advanced information, such as methods of engagement, whether this was an inbound or an outbound lead. How much time prior to the shipment picking up did you engage with said carrier? Where's the carrier based? These questions, though only like marginally more advanced, greatly broaden the scope of the questions you can answer and the analyses that you can do down the line. In this way, comprehensive data collection is really an investment of the problems that you could solve down the line. So what we're going to cover, why is it important to leverage your data. We'll hit on a couple of the metrics that are most important to you all. We'll also highlight a couple pitfalls to avoid when going through your own analyses. Coming out of this, hopefully you'll have a better idea of how to use your own data to decrease dwell time. You'll also see how reusing carriers increases reliable capacity and lowers your operational costs. And again, you'll be taken away with a few common data pitfalls to avoid. So for this first case study, we're going to do a simple analysis of dwell time. You'll see how we use multiple data fields in order to derive actionable insights and action items into how individual facilities can be made more efficient. For this case study, we took one of our large CPG customers who are generating a ton of data across all of their facilities each day. We're going to focus on 14 of their key facilities in the last 6 months. This time period of the last 6 months is pretty important to our analysis here, as we're looking at the most relevant data. What we're trying to do here is really encapsulate any operational changes that may have occurred and making sure that the data that we're looking at is the most relevant for any sort of actions that we might recommend as a function of this analysis. The goal here is going to be to recommend facility changes, either in management or headcount, in order to reduce dwell times and ultimately detention that is paid out, decreasing operational costs. So we have a chart here that is visualizing dwell time by facility. Each line here represents a different facility, colored, so they each kind of stick out. What you see across the x-axis are the days of the week. So we can see, for example, that dwell time across all of these facilities tends to be pretty high, particularly on Monday, and kind of decrease as we go throughout the week. DC5 kind of being at the bottom for Wednesday through Saturday means that typically it has lower average dwell times than, say, a facility like DC1, who's closer to the top of the group, at least on days like Wednesday and Thursday. Now, in order to get some sort of actionable insight, it wasn't enough to just look at average dwell times by facility by day, but we actually need to double click into the data to get a better idea of where intervention is most needed. So now what you have on the top chart is still, we're still looking at dwell time hours by facility, each bar representing a different facility. The height of the bar, the greater the dwell time. We've filtered this to only look on Mondays, but what we've overlaid and what you didn't get in the previous chart, we have black dots now representing the total number of shipments that we see on average for particular Mondays. So the way that you would kind of look at this chart in a big picture is if you look at the largest bar, DC2, it has an average dwell time of 4 hours, seeing close to 1,000 shipments per Monday with a dwell time that is well above the average across all your facilities. Now we can double click one level further into DC2. In the bottom chart, we can actually see the dwell times per day, honing in on that single facility. We see that Monday's dwell times are pretty high, but that the dwell times on other days of the week, like Tuesday and even Wednesday to a lesser degree, are smaller than what we observe on Monday. So one recommendation that we made to this shipper in working with them was, can we rebalance either the shipment volume or maybe headcount between Mondays and Tuesdays to maybe balance this out a little bit so that such a high volume day like Monday is not seeing such increased dwell times for all 1,000 shipments moving through this facility.
Great. Phil's case study is about utilizing data that you already have. This case study is about making theory when you don't have data, and then being able to prove whether or not you were right. So one key thesis at Transfix is the fact that reusing carriers allows you to hit a better level of automation / operation internally, but also gets you the best rate in the market. So in this example, this is us opening a lane. You're seeing in January 1st of 2019, we're trying to get a decent amount of carriers. And as the few months goes, we're trying to understand the market better by adding more carriers into this lane. Once we hit a tipping point around March, April, you're seeing that the number of distinct carriers we get on this particular lane goes down. As that goes down, our internal operation goes up. That's the green line. It's fairly self-explained, but that's a really key understanding for us to prove. As we're giving the theory now is that as we're giving the carrier that have a better service on this lane more freight, we should be able to see our rates go down. And if you, so that's the theory. How do we prove it? If we go to the next slide, in here you're seeing the graph on the right represents how many shipments do we give each carrier per week. As we're giving less than 10, you can see that not only we're getting very high rates, but we're also getting really, really high volatility between the highest rate and the lowest rate. As we move forward and are able to give carriers with better service more freight, you're seeing that like the delta between the highest rate and the lowest rate keeps like decreasing, but also the rate overall is highly decreasing. And when we reach carriers where we're able to give them over 60 freight per week, that's where we're hitting high efficiency here.
Jonathan, this is Jeff here. I just want to see if I can sum up the key takeaway here, and let me know if this is right. But I think so. You're saying that identifying reliable carriers and using them more frequently, that leads to reduced rates. Is that right?
That's right. That's the data here doesn't lie. It shows that like you're getting the best rate. It also has a side effect of reducing volatility between your rates, which in this current market is extremely important.
Cool. Like I said at the beginning, I wanted to touch on a couple pitfalls to avoid when you guys are all analyzing your own data. Great. So the first one is to make sure you identify and address any red herrings that you may see within your data. Now, what is that? What is a red herring when it comes to data analysis? Typically, red herring meaning there's something fishy going on within your data that may lead you to conclusions that are faulty. A simple example here could be data quality issues. When working with some of our customers, I've seen that manual data entry is a huge opportunity to introduce errors into your data collection processes, making any sort of analysis that you do down the line more difficult and more error prone. Whether it's typing in St. Louis and the first time you abbreviate it, other times you spell out Saint, or you have two different people kind of entering different data from different time periods, that is an opportunity to introduce error in your data collection process. There are very simple mechanisms both in Excel along with any other database technologies, if you use them, to kind of reduce the likelihood of introducing these manual data entry errors into your pipeline. Another example could just be bad data points that you've collected. If your carrier cost data set says that you paid $1 on a shipment from Elizabeth to Miami, chances are that's wrong, and that's going to affect your analysis down the line, whether if you're looking at the average cost, let's say. If a carrier was waiting at your facility for 10 days, hopefully something is wrong with the data. But these two cases are examples of where basic sanity checks on whatever metrics you are collecting can help make sure that any analysis down the line is more accurate. A simple sanity check to identify outliers in the min or the max are great, because then you could just remove them and make sure your analysis has the highest degree of fidelity. Second, I encourage you all to always make sure you're comparing apples to apples. Another way to say that is just make sure that the comparisons that you are making are relevant. In the first case study, we looked at the last 6 months of facility data. The goal there was really to kind of capture the state of these facilities as they stand today, so that any recommendation that we are making is hyper relevant to the current state and any operational changes that may have been made recently. Other examples include normalizing to, say, the number of shipments moving through a facility, normalizing your dwell times to head count or hours of labor, help in a similar way put your data and your analysis, make sure you're comparing apples to apples.
The final pitfall to avoid is like you can trust your data up to a certain level. Your data tend to be skewed based on who you are. Just your own buying power can influence how you're buying within a market. And if you're only looking at that view, you may not see the full pictures. We try to always validate. We first validate every theory we have with our own data, and then we always try to see which third party we trust most within to provide ourselves the right benchmarking to understand how we're moving compared to the market. Finding a third party you can trust and that you can easily pull this benchmark from, constantly comparing with your own data is extremely important.
Excellent information there, guys. We do have some questions if you have some time.
Yep, of course.
Great. The first question is, how much do you trust your predictive algorithm?
Well, that's a great question. We're not trying to predict, like, this is very different from predicting the stock market. This is, we're not trying to make a big bet and go from there. We trust our predictive algorithm to an extent where we introduce human quite often to catch the outliers. So we use this process called human in the loop. That's a very common data science process where humans are involved in the process to catch the outlier, fix them, and fit them back into the model so that the model keeps getting smarter and smarter over time. So what that has like great side effects of if you're by yourself trying to from scratch create rates for 100 shipments, it's going to take you a lot longer than if an algorithm you trust predicts 100. You're just scanning through them to make sure they're all valid and finding the one out of the 100 that isn't. We're never going to hit like a bullseye 100% of the time. That I don't think any predictive algorithm in any field can do that today. We do have but to show you a little bit how much we trust this algorithm, we actually build different products on top of it. So we have two in particular that comes to mind. The first one, anybody can actually log into our website, type in like a pickup and a destination, and they will see a rate right away. This is not human touched. It goes straight to our machine learning model algorithm and comes back with a rate, and this is the rate. Because we trust it, we will obey to the rate, even if it's wrong. And hopefully it's not. Another example of a product that we have that show how much we trust this algorithm, but also our customer trusts this algorithm. We've recently introduced Hazmat as a capability, and because it's new to us, we may not be able to buy at market. But that's not a reason why our customers should pay for the cost of us learning. So what we've decided to do is we're looking at what our algorithm comes back for Hazmat in any given lane. If we buy worse, we're not passing on those costs to the shipper, or we're passing like very minimal amount of cost to shippers. And if we're buying better than what our algorithms say, we're actually going to be saving the revenue between us and our customer. The fact that we're able to have a product out there based on this that customer are trusting shows that like we're not the only one trusting our pricing, our customer are, and that's very powerful.
Excellent. We have another question. How far out can you forecast?
Jonathan, I'll take this one. Really, Jeff, as far as you want. But there's kind of a catch with that. With each forecast that my team puts out, we also attach with it a level of uncertainty. And that's important. You know, naturally, if you open up your phone and you look at the 10-day weather forecast, you're going to understand that there's probably some accuracy to it, but you're going to discount it a little bit with the understanding that it's 10 days out and a lot is subject to change, as opposed to a forecast this afternoon, which hopefully has much less uncertainty, and you can use that forecast with higher fidelity. So to that point, you know, we ship out forecasts, you know, same day, 1 week out, 6 months out, 12 months out, but it's always coupled with that understanding of the further out you forecast, we're a little bit more uncertain and things could be subject to change.
Okay. We do have a forecasting follow-up there. What is closer to the truth? Forecasting in this industry is closer to forecasting the weather or the overall economy?
I'm not trying to play both sides of this, but it is a little bit of both. I think like those paying attention to the economy, we really care about the undercurrents within the freight industry and various macroeconomic factors that are crucial to understanding where the market is going to be, 1 year out, 2 years out, 3 years out. Like Class 8 truck orders is a very specific supply side metric that we keep an eye of because we believe it is a leading indicator on price movements. But I'd say like kind of predicting the day to day or a little bit more short term is probably more akin to the weather. Tying it back to my previous comment, we very much care about and we put out a 10-day forecast, understanding that maybe it will change a little bit between then and now. But again, it's kind of attached to that uncertainty, just like you would in understanding like the weather forecast.
All right, excellent. I think that's it for the questions right now. A lot of great actionable information there. I do want to remind everyone that this webinar will be available for replay at the link provided. It'll also be available for download. Otherwise, you can visit transfix.io for more information. My thanks to Jonathan and Phil for their time. Thank you to everyone who joined us today for this Inbound Logistics webinar. Have a great day, everybody.
Thank you, Jeff.
Thank you.